When I am solving proportions, I'm solving equations in which one ratio equals another ratio. In algebra, we do this using cross multiplication. So for ratio A divided by B equal to ratio C divided by D, I cross multiply, meaning I multiply A times D, and I set that equal to B times C. In earlier math classes, you learned other strategies for solving proportions. For example, there's a great 7th grade strategy for this first one. I noticed that 2 times 5 gives me 10, so I can just multiply 9 times 5 to find x. X is 45. That's a great strategy for checking your work, but it won't work for most algebra level proportions. So if there's an expression in your equation, that strategy won't work. Therefore, we're just going to go ahead and use cross multiplication even for these easy examples, and you can use those prior strategies to check your work. All right, 9 times 10 equals 2 times x. And I could just as easily say 2 times x equals 9 times 10. So 9 times 10 equals 2 times x, which I'll write as 2x. After I have multiplied 9 times 10, 90, I now have an awesome one-step equation, 90 equals 2x. So just one inverse operation, dividing both sides by 2, and I have my solution, x equals 45, which is great because that's what I got earlier. Let's keep going. B times 9 equals 81 times 4. I'm going to write b times 9 as 9b because that is more sophisticated. Equals, 81 times 4. Yuck. That is not a super fun computation. So 81 times 4, 324. And then I need to divide both sides of my equation by 9. And yet again, another unfun computation. 32 divided by 9 is 3. This is not the best example ever, guys. Sorry. Okay, so 324 divided by 9 is 36. And that is my solution, b equals 36. Notice that 7th grade strategy works here. 9 times 9 gives me 81, so b is just 4 times 9. I want to point out, in cases where we do have these kind of unpleasant computations, I could have, instead of multiplying 81 times 4, I could have first divided both sides of my equation by 9. That's okay. 9 is a factor of the left-hand side, and 9 is a factor of the right-hand side. This isn't what's on your notes page, but this is a great strategy to keep in mind. So 9b divided by 9 is b. 81 divided by 9 is 9. So there you go. There's an easier way to find my solution, b equals 36. So if you see a common factor of the left and the right-hand side, you can simplify your computation by dividing by that factor. Onward to algebra level proportions. 4 times 2 equals 8 times m minus 8. When there's an expression in your equation, you will have parentheses in your cross multiplication, and you will need to use the distributive property. So I have 4 times 2 equals 8 times m minus 8. So 8 is being multiplied by that whole expression. For sure, the very most common mistake that students make with proportions is they write 4 times 2 equals 8m minus 8. We're multiplying 8 times the whole expression m minus 8. So parentheses and then distributive property. 4 times 2 is 8. Distributive property, 8m minus 64. Just a two-step equation, not so bad. So let's add 64 to both sides, and then I have 72 equals 8m. Almost done. Yay. And I have my solution, m equals 9. Pretty easy to check this one. 8 divided by 2 is 4. So does 4 divided by 9 minus 8 equal 4? Yep, 4 divided by 1 is 4. Last example. That's the fun part. So 10 times x plus 10, so not just 10x plus 10, 10 times x plus 10 equals x times 5, or 5x. Distributive property, I get 10x plus 100 equals 5x. This is a great example of a case where I may want to not follow my general strategy of always subtracting the smaller variable. If I subtract 5x, I end up with 0 on the right-hand side, and then I have to do an additional step. However, if I just subtract 10x to start with, then I have just a one-step equation that remains. So let's go ahead and divide both sides by -5. And then I'm done. My solution is x equals -20. Since the right-hand side is 5/10 or 1/2, I'm hoping that's what I get when I plug in -20 for x. So -20 plus 10 is -10. -10 over -20 is 1/2. So I am correct.